Good morning. This is Miss George, and today we're going to be talking about physical properties and changes as well as chemical properties and changes. Right, properties of matter are used to identify and differentiate between different substances. And you would say, why do I need to know about properties, chemical and physical? Well, this is the reason. So that you can differentiate between substances that might have a lot of similarities, but a few properties would be different, and that would help you differentiate between them. Okay, physical properties of matter are properties that can be observed or measured without changing the identity of that material. So physical property is a property that you can use your senses, your five senses, to determine without actually destroying or changing the material. That is physical property. We're looking at intensive physical properties. Intensive physical properties do not depend on the amount of matter present. They are used to identify a substance. For example, density, we talked about in an earlier video, is an intensive physical property. No matter how much of a substance is present, the density will always be the same for that substance. So if I have a big block of gold or a tiny bit of gold, they're going to have the same density of 0.9 gram per centimeter cube. Other examples: solubility, conductivity, melting point, boiling point are other examples of intensive physical property. Extensive physical properties. They depend on the amount of matter present, and they will change frequently. For example, mass, length, and volume change frequently, and therefore, they're dependent on the amount of matter present. Therefore, they are extensive physical properties. So here, I have a little quick check exercise. Label the following properties as intensive or extensive physical properties. Density. We talked about density a little while ago. Density is an intensive physical property because it does not depend on the amount of matter present. Height would be an extensive physical properties because I can have a block of wood that is 9 centimeters high and I can cut it in half and it would be 4.5 centimeters high. Okay, freezing point is an intensive property because no matter how big the block of ice or tiny the block of ice, it would have the same freezing point as 0 degrees Celsius. Volume changes with the amount of matter present, so that would be an extensive property. Color. Color is an intensive property. Now, that means color is an inherent property of a matter. No matter how big or small that piece of material is, it would have the same color. So color would be an intensive property. Solubility is an intensive property. Okay, solubility, for example, salt in water would not change depending on the amount of material, amount of salt you're adding into water. It would be the same. So therefore, solubility would be an intensive property. Now we're looking at chemical properties of matter. Chemical properties describe the potential of a substance to undergo a chemical change. And examples of chemical properties of matter are flammability, pH, reactivity, and toxicity. Okay, here's a quick check. And you will tell me whether we're looking at a chemical or a physical property. pH is equal to 4. Would you call that a chemical or a physical property? It would be a chemical property. pH is equal to 4 is a chemical property. Smells sweet. Now remember, you don't have to alter the substance to figure out its smell. Okay, so therefore, the smell is a physical property. Reactive in water. Now this, to determine whether it is reactive in water, I do need to add water to the material, and that would alter the material, and therefore reactivity in water is a chemical property. Brown in color. Brown in color. The color is always a physical property. Okay, I don't have to alter the substance to determine the color. So therefore, color, brown in color, is a physical property. Physical change is a change in the size, shape, or state of matter that does not change the identity of the substance. Okay? For example, ice cream melting is a physical change. I can refreeze that ice cream, get the ice cream back. Wadding a piece of paper is a physical change because I did not change or alter the identity of the substance. It's still paper. Okay, breaking glass. I broke the glass into smaller pieces, but all the smaller pieces are still glass. So therefore, that was a physical change. Chemical change is a change that occurs when a new substance is formed. So that's the key. In a physical change, there is no new substance formed. Some of it is reversible. Whereas in a chemical change, a new substance is formed and it is irreversible. And examples are given here. Burning wood is a chemical change. So also formation of rust. When rust is formed, that is a chemical change. Photosynthesis that happens in the leaves is a chemical change. So also is neutralizing an acid is a chemical change.